June 4, 1942. Dawn breaks over Midway Atoll as Japanese carriers Akagi, Kaga, Soryu, and Hiryu launch their strike against the American base. Captain Tomeo Kaku stands on Hiryu's bridge, confident in his navy's supremacy. Japan's Kido Butai has dominated the Pacific for 6 months without defeat. The carriers beneath his feet represent the cutting edge of naval aviation, vessels that had struck Pearl Harbor and swept across the western Pacific like a typhoon. By noon, all 4 carriers will be burning wrecks at the bottom of the Pacific. But that immediate tactical disaster, devastating as it appears, masks a far more terrifying strategic reality that Japanese naval officers are only beginning to comprehend. The mathematics of carrier production are about to reveal an industrial disparity so vast, so overwhelming, that no amount of tactical brilliance or operational skill can overcome it. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. In a cramped office at the Navy Ministry in Tokyo, Captain Minoru Genda reviews intelligence estimates of American carrier construction. The numbers seem fantastic, almost deliberately inflated by enemy propaganda. The Americans claim they will build 24 fleet carriers of the Essex class alone, 24 carriers displacing over 27,000 tons each. Genda's pen hovers over the page. Japan possesses exactly 6 fleet carriers operational at this moment. Building a single fleet carrier requires 2 years minimum using Japan's most advanced shipyards. The United States Navy had commissioned USS Essex on December 31, 1942. The keel had been laid just 20 months earlier. 20 months from laying the keel to commissioning a 30,000-ton fleet carrier, Genda checks the intelligence files again. The data is consistent across multiple sources. Newport News Shipbuilding constructed Essex in an impossibly compressed timeline that defied every assumption about shipbuilding capacity. Japanese naval doctrine has been built on quality over quantity. Each carrier represented a masterpiece of engineering, a carefully crafted instrument of naval power designed and constructed by master shipwrights. The newest Japanese fleet carrier, Taiho, had been laid down in July 1941. She would require 32 months to complete, emerging as a sophisticated design with armored flight deck and advanced damage control systems. 32 months for Japan's most advanced carrier, 20 months for America's mass-produced Essex. The disparity troubled senior officers who understood what these construction timelines actually meant. Not that American carriers were simpler, though they were. Not that American engineers worked faster, though they did. But that the Americans had transformed carrier construction from artisanal craftsmanship into systematic mass production, applying the same principles that had made Detroit the automotive capital of the world to the business of building instruments of naval warfare. Vice Admiral Takejiro Onishi studies production reports in his office overlooking Tokyo Bay. The Imperial Japanese Navy had begun the war with 10 fleet and light carriers. 18 months into the conflict, Japan had managed to commission exactly 3 additional fleet carriers, all of which had been under construction before Pearl Harbor. Junyo and Hio were converted from luxury ocean liners, not purpose-built warships. Only Taiho represented genuine wartime carrier construction, and she would not be ready until March 1944. The Americans, meanwhile, had begun serial production of the Essex class at a scale that seemed incomprehensible to Japanese planners. Not one ship at a time in a single yard, but multiple ships simultaneously in multiple yards, each following an identical design that allowed for standardized components, interchangeable parts, and assembly line techniques adapted from automobile manufacturing. Onishi pulls out a map showing American shipbuilding facilities. Newport News, shipbuilding in Virginia, Philadelphia Navy Yard, Brooklyn Navy Yard, Norfolk Navy Yard, Bethlehem Steel's Fall River Shipyard in Massachusetts, each yard capable of constructing multiple carriers simultaneously, each drawing on a vast industrial infrastructure that had been developed over decades of commercial shipbuilding and automotive manufacturing. Japan possessed 2 shipyards capable of constructing fleet carriers, Mitsubishi at Nagasaki, and Kawasaki at Kobe. Both were operating at maximum capacity. Both were experienced and skilled. Both represented the pinnacle of Japanese naval architecture. But 2 yards building 1 carrier each could not compete with 5 American yards building 4 carriers each. The mathematics were unforgiving. The first Essex-class carrier had been commissioned in December 1942. By April 1943, she was joined by Lexington, marking 2 fleet carriers in just 4 months. Then came Yorktown in April, Intrepid in August, Hornet in November, Franklin in January 1944, Ticonderoga in May, Randolph in October. The pace was accelerating, not slowing. Intelligence officers at the Navy Ministry compiled reports that senior leadership struggled to accept. The American production projections suggested that by mid-1944, the United States would operate more Essex-class fleet carriers than Japan had built of all types during its entire history. This wasn't propaganda. This wasn't exaggeration. This was the systematic application of American industrial capacity to naval warfare, and it was unstoppable. Commander Toshikazu Omai, attached to the combined fleet staff, reviews captured American documents from Guadalcanal. Among the routine reports and operational orders, he finds something that makes him pause. A memo discussing supply schedules for Essex-class carriers under construction. The document mentions CV-9 through CV-21 as ships already laid down or nearing completion. 13 Essex-class carriers in the pipeline, and the memo is dated August 1943. Omai does the calculation. If the Americans maintain their current pace, they will have 17 Essex-class carriers operational by late 1944. 17 fleet carriers, each capable of operating 90 to 100 aircraft, each displacing over 36,000 tons fully loaded, each equipped with the most advanced radar and communications systems available. Japan's entire carrier force at the peak of its strength in December 1941 had numbered 10 carriers. The Americans were building nearly twice that number of more advanced, more heavily armed, more capable ships in less than half the time it had taken Japan to build its pre-war fleet. But the Essex-class carriers represented only part of American production capacity. Intelligence reports documented another class, smaller and cheaper, being mass-produced at an even more staggering rate. The Independence-class light carriers, 9 ships converted from Cleveland-class light cruiser hulls, all commissioned within 12 months during 1943. Each carried 33 aircraft, making them equivalent to Japan's smaller carriers like Zuiho or Shoho. 9 light carriers in 12 months. Japan had commissioned 3 light carriers during the same period, all conversions from existing hulls that had been started years before the war. The systematic nature of American production was revealing itself as fundamentally different from anything Japan could achieve. Omai writes a confidential assessment for Admiral Minachi Koga, Yamamoto's successor as Combined Fleet Commander. The report is blunt, almost brutal in its mathematical precision. At current production rates, the United States will commission more carrier tonnage in 1944 alone than Japan has built in its entire naval history. The sentence sits on the page like an indictment. The fundamental problem was not Japanese inability. Japanese shipwrights and naval architects were skilled, experienced, capable. Taiho represented one of the most sophisticated carrier designs in the world, with innovations in armor protection and damage control that surpassed American designs in certain aspects. Japanese carriers had consistently demonstrated combat effectiveness, carrying elite pilots and advanced aircraft into battle. The problem was capacity. Japan's industrial base could not scale. Building one sophisticated carrier at a time produced excellent individual ships, but couldn't match an opponent building acceptable carriers at a rate of 1 every 2 months. The Americans had solved a different problem than the Japanese, and in doing so had rendered Japanese solutions obsolete. The concept was brutally simple. Rather than building perfect carriers that took 3 years to construct, the Americans built good enough carriers that took 18 months to construct. Rather than custom-fitting each component and fine-tuning every system, they designed for mass production, standardization, and rapid assembly. Rather than treating each carrier as a unique creation, they treated carriers as products to be manufactured in quantity. Captain Rikihei Inaguchi, serving on the Naval General Staff, reviews pre-war planning documents with growing alarm. Japanese naval strategy had assumed a 6-to-10 ratio in carrier strength would be sufficient to maintain operational effectiveness in the Pacific. Superior training, superior aircraft, superior tactics would overcome modest numerical disadvantages. The strategy had been developed when the Imperial Navy possessed 6 fleet carriers, and the Americans possessed 7. But the Americans no longer possessed 7 fleet carriers. By August 1943, they possessed 13 fleet and light carriers operational in the Pacific, with more arriving monthly. By mid-1944, they would possess over 30 carriers of all types. By early 1945, intelligence estimates suggested 50 or more carriers might be operational. 50 carriers. The number seemed impossible, a figure so absurd it defied comprehension. Yet every intelligence report, every captured document, every reconnaissance photograph of American shipyards confirmed the projections. Newport News had 3 Essex-class carriers under construction simultaneously. Brooklyn Navy Yard had 2. Philadelphia had 3 at various stages of completion. The photographs showed massive industrial facilities with ships in various stages of assembly, huge sections of hull and flight deck being fabricated in specialized workshops and then brought together for final assembly. The Americans had broken down carrier construction into modular components that could be manufactured separately and assembled rapidly, the same technique Henry Ford had used to revolutionize automobile production 3 decades earlier. Inaguchi writes another assessment, this one for circulation among senior staff officers. The conclusion is unavoidable. Japan cannot match American carrier production through conventional shipbuilding. The disparity in industrial capacity, raw materials, and skilled labor makes parity impossible. The only path to maintain carrier strength is through unconventional solutions, conversions, desperate measures, and acceptance that numerical inferiority is permanent. At Kure Naval Arsenal, workers labor on Unryu, the first of a planned class of mass-produced Japanese carriers designed specifically for rapid construction. The design is simplified compared to earlier fleet carriers, eliminating sophisticated features in favor of speed and economy. The goal is ambitious: complete construction in 18 months, using techniques adapted from American methods. But even as Unryu takes shape, the realities of Japanese industrial capacity intrude. Steel shortages delay hull construction. Boiler. Production falls behind schedule because priority has been given to destroyer and submarine construction. Skilled workers are diverted to repair damaged ships returning from combat. The compressed timeline stretches from 18 months to 24 months, then to 30 months. Unryu will finally be commissioned in August 1944, 3 years after her keel was laid. In that same 3 years, the Americans commissioned 19 Essex-class fleet carriers and 9 Independence-class light carriers. 28 carriers displacing nearly 1 million tons combined, carrying over 2,500 aircraft, crewed by over 100,000 sailors and airmen. The original plan had called for 16 Unryu-class carriers to be built. Reality reduced this to 3 completed ships. 3 carriers over 4 years of maximum effort represented the absolute limit of Japanese wartime carrier construction capability. Vice Admiral Jisaburo Ozawa, commanding the carrier forces at the Battle of Philippine Sea in June 1944, faces mathematical impossibility translated into tactical reality. His force includes 9 carriers, the largest Japanese carrier concentration since Midway. The Americans deploy 15 carriers against him, including 7 Essex-class fleet carriers and 8 light carriers. 9 carriers versus 15 carriers. But the raw numbers understated the disparity. Ozawa's carriers operated approximately 430 aircraft total. The American carriers operated 900 aircraft total, more than 2-to-1 numerical superiority in aircraft, but the qualitative gap had also widened dramatically. American pilots averaged 500 hours of flight training. Japanese pilots, rushed through abbreviated training programs, averaged 200 hours. American aircraft were newer, better maintained, equipped with superior radios and weapons. American carriers had advanced radar systems that detected incoming strikes at distances that gave defending fighters time to intercept. American damage control procedures, refined through 2 years of combat experience, gave their ships remarkable survivability. The battle becomes a massacre. Japanese aircraft are shot down in numbers that shock even American pilots, who call it the Great Marianas Turkey Shoot. Ozawa loses 3 carriers and over 400 aircraft. American losses total 3 carriers damaged and 129 aircraft destroyed. The exchange rate is devastating, unsustainable, absolute proof that numerical superiority, backed by industrial capacity, trumps individual quality. After Philippine Sea, Ozawa returns to Japan with 6 carriers. The Americans continue advancing with 14 carriers operational, more joining the fleet monthly. The mathematics have become existential. Japan cannot replace losses. America can sustain losses indefinitely and still grow stronger. Commander Masatake Okumiya, an air staff officer with extensive combat experience, writes a confidential memorandum that circulates among naval aviation leadership. The title is direct, almost defiant in its honesty: The Impossibility of Victory Through Carrier Aviation. The document makes no attempt at propaganda or morale building. It simply presents facts. Japan's carrier pilot training program is producing 100 qualified carrier pilots per month. The Americans are producing 1,500 qualified carrier pilots per month. 15-to-1 advantage in trained manpower, compounding monthly. Every month, the war continues. The Americans add 1,400 more pilots to their personnel pool than Japan can add to its own. Aircraft production tells the same story. Japan manufactures approximately 5,000 naval aircraft per year across all types. The Americans manufacture 27,000 carrier-capable aircraft per year. The ratio is approximately 5-to-1 every year, accumulating advantage upon advantage until the disparity becomes insurmountable. But the carriers themselves represent the most dramatic disparity. Okumiya includes a table comparing carrier construction from December 1941 through October 1944. Japan commissioned 6 fleet carriers during that period, including ships that had been under construction before the war started. The United States commissioned 24 Essex-class fleet carriers, 9 Independence-class light carriers, and 67 escort carriers. 100 total American carriers of all types versus 6 Japanese fleet carriers. The ratio defied comprehension, transcended conventional military planning, exposed the fundamental unsustainability of Japan's strategic position. No tactical brilliance, no operational excellence, no technological innovation could overcome a 16-to-1 disadvantage in carrier production. The escort carriers particularly troubled Japanese planners who understood their strategic significance. Small, cheap, mass-produced carriers built on merchant ship hulls, each carrying 28 aircraft, each constructed in 4 to 6 months at shipyards that had never built warships before. The Americans built them by the dozens, using them for convoy escort, submarine hunting, amphibious support, and training. Japan built 0 escort carriers during the entire war. The concept existed, plans were drawn, but steel shortages, shipyard capacity limitations, and competing priorities prevented construction. Every ton of steel devoted to escort carriers meant fewer destroyers, fewer submarines, fewer fleet carriers. The Americans faced no such trade-offs. They built everything simultaneously because their industrial capacity exceeded all demands. Captain Mitsuo Fuchida, who had led the Pearl Harbor attack and survived Midway, spends time recovering from injuries at a naval hospital outside Tokyo. Fellow officers visit, share news from the front, discuss tactical developments. The conversations increasingly turn to industrial capacity rather than combat tactics. One visitor brings photographs taken by submarine reconnaissance of American shipyards. The images show construction activity on a scale that seems impossible. Hundreds of ships in various stages of completion, crowding slipways and fitting out docks. One photograph shows 7 Essex-class carriers simultaneously under construction at various East Coast yards, their distinctive profiles unmistakable even in grainy reconnaissance photography. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. 7 carriers being built at the same moment. Japan's 2 carrier-capable yards were each working on one ship, using every available resource, operating at maximum capacity. The Americans had 7 carriers under simultaneous construction, and their yards weren't even approaching full capacity. Intelligence estimates suggested American shipyards were operating at 70% of theoretical maximum output, maintaining spare capacity for surge production or emergency repairs. Fuchida studies the photographs with the analytical eye of a professional naval officer. The American carriers appear almost identical in the images. Not similar, identical. Same hull form, same island structure, same flight deck configuration, mass production at its purest expression. Every carrier built from the same blueprint, using the same standardized components, following the same assembly procedures. Japanese carriers were individuals. Akagi, Kaga, Soryu, Hiryu, Shokaku, Zuikaku, each had unique characteristics, custom features, distinctive capabilities. The differences reflected Japan's carrier doctrine evolution over years of design refinement. They also reflected the impossibility of standardization when building one ship at a time over extended periods. The Americans had chosen standardization from the beginning. The Essex-class design was finalized in 1940 and never substantially modified during production. 24 ships built to effectively identical specifications, allowing for training standardization, parts interchangeability, and operational uniformity. A pilot qualified on one Essex-class carrier could operate from any Essex-class carrier. A mechanic trained on one ship's systems could maintain any ship's systems. An operations officer could transfer between ships without relearning basic procedures. The strategic advantages of standardization became apparent in combat sustainment. When USS Franklin was heavily damaged by Japanese air attack in March 1945, suffering over 800 casualties and devastating fires, American repair crews had her back in operation within weeks. The standardized design meant replacement components were available in quantity, repair procedures were well understood, and trained personnel could be transferred from other Essex-class carriers to replace casualties. No Japanese carrier could have survived Franklin's damage, but even if one had, repairing it would have required custom fabrication of components, specialized knowledge of that particular ship's unique systems, and months of work at a major naval arsenal. The Americans repaired Franklin at sea using spare parts and damage control teams that understood the ship because they understood all Essex-class carriers. Admiral Soemu Toyoda, who assumed command of the combined fleet after Ozawa's defeat at Philippine Sea, receives a comprehensive intelligence assessment in September 1944. The document attempts to project American carrier strength through 1945 based on observed construction rates and known shipyard capacity. The projections show 27 Essex-class fleet carriers operational by March 1945, 32 operational by September 1945. The Independence-class light carriers would remain at 9 ships, as the program had been completed. But escort carrier production would continue accelerating, with projections suggesting over 100 such ships by war's end. Toyoda's carrier strength at the same moment numbered 4 operational fleet carriers. 4 ships against a projected 32 American fleet carriers, plus 9 light carriers, plus over 100 escort carriers. The ratio was no longer measurable in meaningful military terms. This wasn't numerical superiority. This was industrial overwhelm, the complete subsuming of one navy's combat power under another navy's production capacity. The final carrier battle of the war occurs at Leyte Gulf in October 1944. Toyoda employs his 4 remaining fleet carriers as decoys, deliberately sacrificing them to draw American carriers away from the main landing areas. The strategy works tactically. American carriers pursue the Japanese decoy force northward, but the outcome demonstrates the fundamental irrelevance of Japanese carrier operations. Admiral William Halsey's Third Fleet employs 17 carriers at Leyte Gulf, 14 fleet and light carriers in his main striking force, plus 3 escort carrier groups supporting the landing forces. Against this armada, Japan sends 4 fleet carriers carrying 116 aircraft total. The Japanese carriers are nearly empty, used as bait because Japan no longer possesses sufficient aircraft or pilots to operate them effectively. All 4 Japanese carriers are sunk. Zui Kaku, the last survivor of the Pearl Harbor attack, goes down fighting. Zuiho, Chitose, and Chiyoda follow her to the bottom. With their loss, Japan's operational carrier force effectively ceases to exist. Several carriers remain in home waters, but fuel shortages, pilot shortages, and aircraft shortages render them immobile. The Americans lose 1 light carrier, Princeton, to a single bomb hit that detonated in her hangar. 700 casualties, the ship abandoned and scuttled. Within 2 months, the Americans commissioned 2 new Essex-class carriers to replace the loss. Japan will never commission another carrier. The final tally of carrier construction reveals the scope of industrial disparity that destroyed Japan's naval power. The United States commissioned 99 carriers of all types during the war. 24 Essex-class fleet carriers displacing over 820,000 tons combined. 9 Independence-class light carriers. 66 escort carriers. Total displacement approximately 1.4 million tons of carrier construction. Japan commissioned 15 carriers during the war, including conversions and ships started before hostilities. 3 Unryu-class fleet carriers. 3 Taiho-class fleet carriers, though only 1 was completed. 9 converted carriers of various types. Total displacement approximately 300,000 tons of carrier construction. The ratio was roughly 4-to-1 in tonnage, but worse in combat capability. American carriers operated larger air groups, possessed better damage control, carried more ammunition and fuel, maintained higher operational readiness. An Essex-class carrier represented more combat power than 2 or 3 Japanese fleet carriers, making the effective combat ratio closer to 8-to-1 or 10-to-1. But even these numbers understated the true disparity. Time mattered. The Americans built their 99 carriers in 4 years, averaging 25 carriers per year. Japan built 15 carriers over 15 years if pre-war construction is included, or 6 carriers over 4 years if only wartime construction is counted. Annual production ratio was 12-to-1 in America's favor. Captain Toshikazu Ome, now assigned to post-war analysis duties, writes a comprehensive assessment of naval aviation in October 1945. The war has been over for 2 months, Japan occupied, the Imperial Navy dissolved. Ome has access to complete records, full intelligence files, and the brutal clarity that comes from comprehensive defeat. His analysis focuses on the industrial foundations of naval power. Japan lost the carrier war not in 1942 at Midway, though that battle marked the turning point tactically. Japan lost the carrier war in the 1920s and 30s, when American industry developed mass production techniques that could be applied to military construction. Henry Ford had revolutionized automobile manufacturing with the assembly line in 1913. By the 1920s, American automotive plants were producing millions of vehicles annually, using standardized components and systematic construction methods. The workforce was trained not in artisanal craftsmanship, but in specialized procedures that could be taught in weeks rather than years. When America needed to build carriers in quantity, the entire automotive industrial base converted to military production. Workers who had built cars built carriers. Factories that had produced automobile engines produced marine turbines. Suppliers that had manufactured automotive components manufactured naval equipment. The transition was rapid because the fundamental manufacturing principles were identical. Japan's shipbuilding industry had no equivalent industrial base to draw upon. Japanese automobile production in 1941 totaled approximately 48,000 vehicles. American automobile production that same year exceeded 4 million vehicles. The ratio was 80-1, a disparity that reflected fundamental differences in industrial capacity, manufacturing philosophy, and economic scale. Those 4 million vehicles represented 4 million sets of engines, transmissions, electrical systems, brakes, steering assemblies, each built to precise specifications with interchangeable parts. The companies producing them, Ford, General Motors, Chrysler, possessed manufacturing expertise that translated directly to military production. They understood mass production, quality control, supply chain management, and worker training at a scale Japanese industry had never attempted. When William Knudsen, former General Motors president, took charge of American war production in 1940, he brought automotive manufacturing principles to naval construction. The results were revolutionary. Essex-class carriers used standardized components manufactured by automotive suppliers. Engines were produced by companies that made car engines. Electrical systems by companies that made automotive electrical systems. Pumps, valves, piping, all of it drawn from an industrial base that produced millions of such components annually for civilian vehicles. Japan's carriers were built by shipyards using shipyard techniques, every component custom-ordered from specialized naval suppliers, every system designed specifically for that particular ship. The supply chain was narrow, specialized, vulnerable to disruption. When American submarines began sinking Japanese merchant ships in 1943 and 1944, the flow of raw materials to shipyards collapsed, steel production dropped, engine production slowed. The Unryu-class carriers under construction sat incomplete in their slipways, waiting for materials that never arrived. American carriers faced no such shortages. The industrial base was vast, diversified, redundant. If one supplier couldn't deliver, another supplier filled the gap. If one shipyard fell behind schedule, other yards accelerated production to compensate. The system had flexibility that came from abundance, resilience that came from scale. Omei's final conclusion is stark. Modern naval warfare is decided by industrial capacity before the first shot is fired. Tactical skill, operational art, technological sophistication all matter at the margins. But the fundamental equation is production capacity multiplied by time. The nation that can build more ships faster will inevitably overwhelm the nation that cannot, regardless of individual ship quality or crew proficiency. Japan had entered the war with a fleet designed for a limited conflict, a sharp, decisive battle that would establish dominance and force negotiation. The strategy assumed American unwillingness to sustain heavy losses, assumed limited American industrial capacity, assumed that quality advantages would offset numerical disadvantages. Every assumption proved catastrophically wrong. The Americans were willing to sustain heavy losses because they could replace them. Their industrial capacity wasn't limited, it was effectively unlimited relative to Japanese needs. Quality advantages didn't offset numerical disadvantages when the numerical disadvantages exceeded 10-1, and the gap widened every month as American production accelerated and Japanese production declined. The human cost of this industrial disparity manifested in ways that transcended mere statistics. By war's end, the United States had trained over 100,000 naval aviators. Japan had trained perhaps 15,000 carrier-qualified pilots during the entire conflict. American pilot training programs produced skilled, confident aircrews who flew reliable aircraft from well-maintained carriers. Japanese pilot training, degraded by fuel shortages and trainer aircraft shortages, produced minimally qualified pilots who flew worn-out aircraft from damaged carriers. The quality differential showed in combat exchange rates. At Philippine Sea, American pilots achieved a kill ratio of roughly 10-1, destroying 10 Japanese aircraft for every American aircraft lost. At Leyte Gulf, the ratio was similar. By 1945, when kamikaze attacks replaced conventional carrier aviation, Japanese pilots were flying one-way missions because they lacked the training for combat maneuvering and the fuel for return flights. The kamikaze campaign itself reflected industrial desperation. Unable to match American carrier production, unable to train sufficient pilots, unable to produce enough conventional aircraft, Japan resorted to using pilots as guided missiles. The tactic inflicted damage, sinking several dozen American ships and damaging hundreds more. But it couldn't stop the American advance because American industrial capacity replaced losses faster than kamikazes could inflict them. USS Franklin, hit by kamikaze attack in March 1945, suffered catastrophic damage. Over 800 casualties, her flight deck buckled, her hangar consumed by fires, her engineering spaces flooded. The crew fought for hours to save the ship, succeeded, and she limped to Pearl Harbor for repairs. Within months, Franklin was being repaired and would have returned to service if the war had continued. The Japanese carrier Taiho, hit by a single submarine torpedo in June 1944, exploded and sank within hours. Poor damage control, inadequate firefighting equipment, and design flaws in her fuel system turned a survivable hit into a fatal wound. 600 sailors went down with her, including experienced aviation personnel who could not be replaced. The difference between Franklin's survival and Taiho's loss exemplified the broader industrial disparity. American carriers were designed for damage survival, with redundant systems, extensive firefighting equipment, and trained damage control parties. Japanese carriers were designed for offensive power, maximizing aircraft capacity and operational speed while accepting greater vulnerability. The choice reflected each navy's strategic assumptions. Japan had assumed brief, decisive battles where carriers would strike first and withdraw before counterattack. Damage control was less important than initial striking power. America had assumed extended campaigns where carriers would sustain damage and needed to remain operational. Damage control was as important as offensive capability. The American assumption proved correct. The Japanese assumption proved fatal. By August 1945, when Japan surrendered, the disparity in carrier forces had reached its absolute peak. The United States Navy operated 28 fleet carriers, 9 light carriers, and 71 escort carriers. 108 operational carriers total. Japan operated 0 operational carriers. Several ships remained afloat in home ports, but fuel shortages and lack of aircraft rendered them immobile. The final irony was that American carrier production was still accelerating when the war ended. 6 additional Essex-class carriers were under construction, scheduled for completion in 1946. Plans existed for an improved design, the Midway class, 3 of which would be completed shortly after war's end. If the conflict had continued into 1946 and 47, American carrier strength would have exceeded 150 ships. Japan had planned for 14 Unryu-class carriers to replace Midway losses. 3 were completed. 6 were laid down, but never finished. 5 were cancelled before construction began. The entire program represented maximum Japanese effort, drawing on every available resource, and it produced 3 ships over 3 years. The Americans produced 33 fleet carriers in the same period, plus 9 light carriers and 71 escort carriers. Rear Admiral Mitsuo Fuchida, in post-war interviews with American historians, offered perhaps the most succinct analysis of Japan's carrier aviation defeat. "We lost the carrier war," he said, "before we ever attacked Pearl Harbor. America's industrial capacity was decisive. Not our tactics, not our aircraft, not our pilots. Their factories." The statement captured the essential truth. Midway mattered tactically. Philippine Sea mattered operationally. But American victory was guaranteed by industrial capacity that Japan could never match, could never counter, could never overcome through any conceivable military excellence. The Essex-class carriers represented not technological superiority but systematic superiority, the application of mass production principles to naval warfare. Captain Minoru Genda, the architect of Pearl Harbor attack planning, reflected on the carrier war in his memoirs written decades later. He recalled reviewing American production figures in 1942 and understanding immediately that Japan faced mathematical impossibility. 24 Essex-class carriers represented more tonnage than Japan's entire pre-war carrier force. The Americans were building Japan's total carrier capacity in less time than Japan had taken to build it originally. "We knew," Genda wrote, "that America possessed greater industrial capacity than Japan. We did not understand how much greater. We calculated perhaps 2-to-1 advantage, maybe 3-to-1 in shipbuilding. The actual ratio was 10-to-1, 20-to-1 in some categories. No tactical genius can overcome such disparity. We were attempting to fight an industrial superpower with an industrial base that resembled a European middle power. The outcome was certain from the beginning. The lesson proved enduring. Modern naval warfare is fundamentally economic before it becomes military. The nation that can build more ships faster, train more personnel, produce more aircraft, will defeat the nation that cannot, regardless of individual weapon quality. Industrial capacity has always mattered in warfare, but the carrier battles of the Pacific demonstrated that in modern warfare between industrial powers, production capacity matters more than combat performance. Japan had built 6 exceptional fleet carriers and fought them skillfully. America had built 99 adequate carriers and fought them systematically. The adequate carriers won not because they were better designs, though some were, but because there were so many of them that Japanese forces drowned under the weight of numerical superiority. Quality became irrelevant when outnumbered 10-to-1 by competent opponents. The post-war Japanese Maritime Self-Defense Force learned this lesson well. When Japan rebuilt its naval power in the 1950s and 60s, the focus shifted entirely to quality over quantity. Limited by constitutional restrictions and aware that Japan could never match superpower production capacity, Japanese naval planning emphasized sophisticated individual ships designed for specific defensive missions. The carrier aviation capability was never rebuilt. The United States Navy, by contrast, maintained its carrier-centric doctrine and industrial capacity. The Essex-class carriers served into the 1970s, many modernized repeatedly to operate jet aircraft. The principles established during wartime production continued, with carriers built in standardized classes using systematic production methods. The Forrestal class, Kitty Hawk class, and Nimitz-class carriers all reflected lessons learned during Essex-class construction about standardization, interchangeability, and production efficiency. The numbers from World War II remain almost incomprehensible. 24 Essex-class fleet carriers built in under 4 years. An average of 1 fleet carrier commissioned every 60 days at the program's peak. Each carrier displacing 36,000 tons fully loaded, carrying 90 aircraft, crewing 3,000 sailors and airmen. The industrial achievement rivaled any manufacturing accomplishment in human history. Detroit's automotive plants had produced 50,000 tanks, but tanks weighed 30 tons each. Aircraft manufacturers had produced 300,000 aircraft, but aircraft weighed 10 tons each. Shipyards had produced fleet carriers weighing 36,000 tons each, complex vessels with thousands of compartments, miles of piping and wiring, sophisticated propulsion systems, elaborate aircraft handling systems, all built to naval standards requiring precision and durability. The Essex-class production program employed over 200,000 workers at peak capacity. Shipyard workers fabricated hull sections and assembled them on slipways. Machinists manufactured turbines and reduction gears. Electricians installed complex wiring systems. Pipe fitters assembled the intricate plumbing required for fuel, water, steam, and compressed air. Joiners fitted out living spaces and operational compartments. Each worker a specialist in their particular task, trained in weeks or months rather than years, performing their role in a systematic production process that valued consistency over artisanship. The ultimate irony was that America's industrial capacity, developed for peaceful commerce, proved more decisive in war than Japan's military-focused industrial base. Detroit's automobile plants converted to military production more easily than Japan's naval arsenals could scale up construction. The commercial infrastructure, commercial expertise, commercial supply chains all translated directly to military application because the fundamental manufacturing principles were identical. Japan had spent decades building military-specific industrial capacity, purpose-built naval arsenals, specialized suppliers, trained craftsmen, all optimized for military production. But optimizing for military production at the scale Japan could achieve meant building perhaps 2 carriers per year maximum. Optimizing for commercial production at the scale America had achieved meant converting that commercial capacity to military production could build 50 carriers per year if required. The disparity reflected deeper differences in economic philosophy and industrial development. America's economy emphasized mass consumption, requiring mass production, creating industrial infrastructure capable of producing millions of standardized products annually. Japan's economy emphasized quality craftsmanship, producing fewer items of higher individual quality. Both philosophies had merits in peacetime. In total war between industrial powers, the mass production philosophy proved overwhelmingly superior. Captain Toshikazu Omae's final assessment, written in 1946 for Japanese naval archives, concluded with a warning for future planners. Industrial capacity, he wrote, is the foundation of modern naval power. No nation should enter war against an opponent possessing 10-to-1 industrial superiority. Tactical skill cannot overcome such disparity. Strategic genius cannot compensate for such imbalance. The war will be decided by production figures before combat begins. Japan learned this lesson at catastrophic cost. Future generations must remember. The 24 Essex-class carriers represented the physical manifestation of that lesson. They were not individually superior to Japan's best carriers in every respect. Shokaku and Taiho possessed certain design advantages over Essex-class ships, but there were 24 Essex-class carriers and only 2 Shokaku-class carriers. The ratio was 12-to-1, insurmountable, decisive, proof that in modern warfare between industrial nations, quantity of adequate quality defeats quality in limited quantity. Hermann Göring had laughed at Roosevelt's promise of 50,000 aircraft annually. Japanese admirals had dismissed estimates of 24 American fleet carriers as propaganda. Both had made the same fundamental error, underestimating American industrial capacity because it seemed impossible that any nation could produce military equipment on such a scale. Both learned the same painful lesson. American industry had been building products on that scale for decades. Applying those techniques to military equipment was merely a matter of conversion, not innovation. The shock that Wehrmacht engineers felt handling the GMC truck, discovering perfect interchangeability, realizing mass production had achieved precision manufacturing, was the same shock Japanese naval officers felt studying Essex-class carrier specifications. The realization that their opponent had solved the fundamental problem of modern war, transforming industrial capacity into military power through systematic mass production. In September 1945, Captain Mitsuo Fuchida tours several captured Japanese carriers with American naval officers. The Americans want to understand Japanese carrier design philosophy, study the differences in approach. Fuchida walks them through Akagi, an Unryu-class carrier that never saw combat, explaining the design choices, the compromises made to accelerate construction, the desperate attempts to match American production. An American officer asks the obvious question, "If you knew you couldn't match our production, why did you attack Pearl Harbor?" Fuchida considers the question carefully. We knew America possessed greater industrial capacity. We believed the war would be short, a decisive early victory, a negotiated peace before American industry fully mobilized. We understood your capability. We misjudged your will to use it. That miscalculation was fatal. The carriers at anchor in Tokyo Bay represent the physical evidence of that miscalculation. USS Essex, USS Lexington, USS Yorktown, USS Intrepid, a dozen more American carriers crowding the anchorage. Japanese carriers absent, sunk, or scrapped, removed from existence. The industrial contest had been decided years before, in Detroit automotive plants and Pennsylvania steel mills and the shipyards that learned to build carriers the way Ford built cars. The mathematics had been unforgiving. Japan could not build 6 carriers to match 24. Japan could not train 1,500 pilots per month to match 15,000. Japan could not produce 5,000 naval aircraft annually to match 27,000. Every equation, every ratio, every comparison revealed the same truth. Industrial disparity had predetermined the outcome. The battles merely confirmed what the production figures had already decided. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.